Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. So here's the question for today. What if the most powerful AI in your company is not the largest model you can buy, but the one trained on data that only you own? That's the idea behind domain-specific AI. These are systems designed to do one thing and do it exceptionally well. Over the past decade, we've seen a clear and repeatable pattern. When problems are tightly defined, when models reflect real operational constraints, and when they are trained on proprietary data, they outperform general-purpose systems in enterprise environments and create durable competitive advantage. That kind of focus changes what performance looks like. These systems are faster, more precise, and more reliable because they are built to perform a single task and optimized end-to-end. Today, we're going to break down this and talk about what it actually takes to get AI into production. And to do that, I'm joined by two of the sharpest minds in the industry, my co-founder and distinguished engineer, Dr. Si, and our VP of Engineering, Michael Wharton. All right, Michael, Zizi, Happy New Year. Happy 2026.
Happy New Year.
Happy New Year. Glad to be here.
I'm really excited about this conversation because this is something we've been circling around for a long time, right? I actually think that this is one of the most important discussions that we'll probably have this year, and because it could drive the most value for a lot of our enterprise listeners. Okay, so what we're going to talk about is domain-specific models. Let me tee this up just a little bit. So since the rise of ChatGPT and large language models, we've talked about this many times, we've seen businesses just kind of rush to adopt that. And there are really many powerful things about that. Large language models are really good at many things. They're really the first instances of AI models that can do many, many things. They can summarize, they can classify, they can generate content. But with that broad capability comes a lot of complexity and uncertainty, right? You know, AI is very jagged, and controlling these systems in a way that is reliable for the enterprise can be really hard. On the other end of the spectrum are domain-specific models, right? That's the idea that you could build an AI system that may do as few as one thing. It's only capable of doing one thing, but it can do it potentially at a superhuman level, right? So when I say, before we jump in too much further, before I say anything more about domain-specific models, Michael, what do you take it to mean when I say that?
Yeah, it's such a broad topic. There's so many different ways to slice it, and it's the reason that we exist, as a company. I mean, we can build domain-specific models on people's proprietary data, and there's a lot of upside to that. But I think about it almost in terms of maybe like a toy example. Like I come from a computer vision background. I know that Zizi does as well. And I think about the arc of history of computer vision classifiers. Like back in 2012, there's that AlexNet moment. It was a major leap forward in ImageNet performance. And for domain-specific use cases, model architectures along those lines can still outperform, these impressive VLMs that you have that are like hundreds of billions of parameters.
Right.
But when you start talking about cost, even if, like, let's say we have two models, it's either this traditional computer vision model or a VLM like Claude Opus 4.5 or something, even if they're at parity with performance, you're talking about at least 4 orders of magnitude size difference between the two. And if you don't need, like, if you literally just need to classify cats versus dogs or something, like that classic example, you don't need a model that can also invent new recipes and write poetry and, translate Japanese to Vietnamese or something.
Right.
Every time you make an inference, you're wasting that capability.
Right. And you hit upon something I think that's really important, is the proprietary data. I think this is going to be a big part of the conversation. So to kind of address the elephant in the room, domain-specific models, we believe very, very strongly at Kung Fu AI that they are really the primary form of AI that most businesses should be leveraging. And that means, by all means, go embrace LLMs. But if you want to spend money and build AI that is going to give you competitive differentiation and advantages, it's almost invariably going to be domain-specific AI. So let's get concrete. Let's talk about a specific example. One of my favorite projects we've done in the recent years is the work with the Triumph Financial Corporation. Zizi, you were instrumental on that engagement, and that is a what I would consider to be sort of a superhuman domain-specific model. Can you describe that work and what that model did?
Oh yeah, definitely. So the company, so the business context is that, looking at the submitted invoices and trying to decide whether it is a good asset to make a purchase. But the main risk is that, some of the invoices may end up being delinquent, like, they end up being not paid by the debtor. So that causes, lost money. And they have a, big internal team spending a ton of time to review like hundreds of invoices per day.
Yeah, hundreds of people doing this manually.
Yeah, and still cannot cover all the invoices because of the volume that's submitted by the truck drivers. So we came in and employ several techniques. Some of them are document AI, because a lot of the information that we're using to determine the risk of an invoice is coming from reading and understanding document accurately. And then second of all, the decisioning model that we built for them needs to consider the historical risk from different factors, and then try to make a decision that's fast, that's accurate, that's using the domain-specific data that's only available to our client.
Right.
So the model that we ended up deploying was the product of their proprietary data, and that's the competitive advantage.
I think you nailed it. And to just kind of reiterate, it's this idea that you can take advantage of data that you have as a company that you may have built up over a decade or more, and leverage that proprietary asset to build AI models that give you real competitive differentiation. That is the number one way we see our clients succeed with AI. And we've just seen it over and over and over again. And I may actually even sound a little frustrated here. I think it's because the rise of large language models in some way, I feel like, has sucked all the oxygen out of the room. And too often, companies, companies are spending billions of dollars on AI initiatives right now. And there are reports that something like, 90% of them failed to make it in production. And I know that we all agree that a lot of the reason is because they're building these systems that are really, really overly complex, right? You start with something like a generative model and you try to have it be completely predictable, and you end up essentially playing whack-a-mole with bugs forever, right? Because of the sort of the jagged capability. There's another aspect of this that I think is really interesting, which is cost, right? Yeah. Reliability, interpretability, lower variance. All of those things you get kind of for free when you downscope the initiative and you really, really focus on solving one problem well. Okay, so Michael, what's an example of a domain-specific model that you've worked on in the last 8 years at Kung Fu AI that you think is really sort of an exemplar of what we're talking about here?
Yeah, so I want to preface what I'm about to say as I think it's really hard not to sound like a negative Nancy about language models. I just want to be abundantly clear. I use the heck out of it. Coding assistants, I think it's table stakes, and it's completely revolutionized how work is done. So I really don't want to discount that. However, there really are certain domains that you still can't even work with unless you have at least some form of text or image documents, or whatever your data looks like. There was this client we had a while ago that it's a really interesting use case. They have these electrical submersible pumps that you bury deep in the ground for mostly industrial applications. And what would happen is they would have these failures that would happen occasionally. And they're very, very expensive pumps, like, 7-figure kind of high quality machinery type pumps. And we found that if we just looked at time series signals that were captured from the pump, so that's things like temperature, pressure, vibration, all sorts of sensors you'd imagine to be on a device like that. You can look at these historical failures and look at all the time series signals leading up to them and predict more than 24 hours in advance, often, if there was going to be an issue, because it turns out that there's this like cumulative degradation that happens where maybe there's like a little pocket of silt that goes in and there's a dynamic event that you can pick up. It took us a while to figure this out. But we built this model that I think it ended up being more than 80% of the time could predict when a pump would fail, even more than a day in advance. And in that case, all you do is just pull the pump and service it and put it back in instead of losing
and remind
7
me,
figures.
When the pumps go down, what was like the daily impact?
Oh, it's definitely well, if it breaks completely, then they have to completely restore it. And I think it could be weeks because some of these places are literally out in the middle of nowhere in like Odessa,
and weren't they? I mean, wasn't it something like $1 million a week in lost revenue or something like that? I mean, it was enormously impactful.
Yeah. I think you're right on the money with the order of magnitude there.
Okay. Yeah. So. All right, so let's say somebody's listening to this and we've convinced them somewhat that, okay, maybe domain-specific models are an interesting approach. How do you know? How do you know what to
What's
build?
the decision?
Yeah, how do you make a
framework?
decision? How do you identify where to go?
Yeah, I think we all have been thinking about this every day when we work for our clients. But yeah, I would love to hear what your thoughts too, but I'm going to throw out a few first. So first factor would be latency, and then the compliance. Whether your data is highly sensitive, whether you're comfortable using a third-party API, and also accuracy on your particular domain. That's the three things that's on top of mind. But
Okay, so unpack that a little bit. So accuracy, obviously the point there is you're in a situation where sort of the uncertainty of whether you're dealing with a hallucination is just not acceptable, right? You just have really, really high accuracy requirements.
Yeah. I mean, let's just talk about some concrete examples. Let's say we wanted to build a model to detect, whether my garage door is open. How would you do that today? Well, I guess my answer today will be very different from 3 years ago even, because 3 years ago there's no well, I guess Google Vision API is there, but so let's go back even more. Maybe five years ago, then maybe your only choice is to take a model that's pre-trained on ImageNet, and then you fine-tune it on your own data.
Right.
Today, you can use ChatGPT API. You can use the GPT API, or you can use Cloud API. You can upload the image, and I think the accuracy is fairly high already.
Agreed.
Maybe 90%, maybe 95%.
Right.
And if your accuracy requirement is not like 99.99999, maybe you're okay.
Right.
Mm-hmm.
However, if you're kind of self-driving car kind of accuracy requirement, then you can see a clear argument.
That's a great example. Yeah.
It is. But I think you also touched on something really, really important, which is, identifying whether a garage door is open. See, that's a problem that is so common, or it's in the sense that it's in the real world, that you could make the argument that, just going with some type of API off the shelf is the way to go, because it almost certainly could handle that scenario really reliably.
Yeah. Is it in distribution or not? Right?
Exactly. Where I think for businesses that are thinking about domain-specific models, almost by definition, the problem you're trying to solve is not something that's out in the public domain or that is common. You're trying to do things like, if you're in healthcare, you're trying to detect, clinical misdiagnoses or conditions, or maybe if you're in banking, we've already talked about loan decisioning. Maybe you're trying to detect fraud. These are all cases where you will probably have proprietary data, and it just wouldn't be feasible to use something like an API, right?
Yeah, absolutely agree. What if you have a drone image, or a satellite image, or a fisheye camera image that's, not common in those training data set that trained GPT-4 Vision or, Claude.
Yeah, that's exactly right. Yeah. Mike, what are some of the things that you look for when you're talking with clients, you're trying to identify opportunities, and you want to make sure that, there's going to be return on investment and that they have the sufficient data?
Yeah, there are definitely a few. I think ZZ touched on some important ones for sure. Just to take his example further, I think about scale a lot. Like Doc AI comes up a lot of times, but if they're trying to make, hundreds of thousands of inferences every hour or something like that, or let's say it's like a loading dock where there are a bunch of different bays with their own garage doors, and you need to assess whether a garage door is open once every 30 seconds or something. It's way too inefficient to just constantly rely on some frontier model that's got, hundreds of billions of parameters or whatever.
Right.
So the cost at scale is a big one. There are also just some things that language models or VLMs simply can't do. Like they can't do, or they're really, really bad at uncertainty estimation. Because, they're famously bad at that because a lot of the benchmarks reward confident guessing.
Yes.
So, you ask a model, hey, how confident are you? There are plenty of studies that look at this, but it's, they'll often say, oh, I'm 70, 80% confident.
Yeah.
But for the most part, there's very little correlation between those confidences and the actual performance. So if confidence estimation is a big part from the client's perspective, I'll ask them about that a little bit more.
What about the data? Like, how do you know? How do you know if a client, we get asked all the time to solve problems, and it's not even clear that they necessarily have the data.
Yeah, data volume is really, really important. Especially if they're trying to do something that is differentiated.
Yeah.
I can't tell you how many times I've talked to a client. They're like, hey, I want to do this amazing thing. I have this incredible vision for this AI system. But the type of data they would need is pretty out of distribution from what you'd expect with a frontier model.
Yeah.
And in the worst cases that I've seen, they have a retention policy that's really short, and they had the data, but then they no longer have it.
Yeah, we've seen that a couple of times.
Yeah.
But there are certain data modalities that just don't even, they're non-starters. Like I mentioned time series signals earlier. There are a couple people that have tried to do, I think Nixta was one of the companies that tried to do a time series foundation model. I haven't really seen that take off all that much. But if you're dealing with sensors and you're doing industrial automation, you can't just copy and paste a time series signal into a prompt and expect anything meaningful.
Yeah.
Yeah, I totally agree.
I feel like on the data side, this is the number one issue. Well, I step back. Data is always the issue with AI, right? We're always dealing with data issues, either data volume or data quality, or the thing you're trying to predict is really rare. For example, fraud or cancer, and so you don't have many instances of that. But that's actually, if you think about it, that's actually a real opportunity for businesses. If they have a collection of data and they have a collection of rare events, they absolutely can leverage that to build.
That's the place to start.
That's the place to start. It really, really is. It's the problem is the opportunity there, right? So on the flip side, now I want to just kind of think about this in an opposite way. How do you know when a domain-specific model is not the right approach?
Do you count coding agents as domain-specific or not? I would think they're general, but
oh, that's a good question. So if you're working with Claude Code or something like that, is that a domain-specific model? I would probably lean towards yes, but you would say no.
That's fair.
No, but you don't think so?
Because I'm kind of on the fence. Coding is more specific than just general language model.
Right.
However, coding is so ubiquitous. Software is the world, and if you can generate code,
I think that's the trick, though. It's really more of a spectrum on how narrow is the task that a model is going to perform.
Okay.
Like in the most extreme case, you have almost think about them like those ASICs, those application specific integrated circuits. Like cameras have very specific tailored hardware that's meant to do some extremely narrow thing, like convert light rays to pixels and or whatever. On one end of the spectrum, you have these hyper-specific things that maybe it's like a garage door detector and that's it.
Yeah.
And then as you get more and more generic, I would put coding agents, fine-tuned language models, and general purpose VLMs way over here. And I think often what we see is that the differentiated use case that's the most going to produce the most value for a client, it's way down here on the spectrum.
Right.
But to your point, I don't think that there's a meaning... Other than scale, there's slight differences.
It's definitely a spectrum. It's blurry. And I do believe that domain-specific models don't have to be single use case. Meaning I do think you can have models.
You can specialize.
You can have
T-shaped kind of model.
Right? Exactly. Yeah. That's exactly right. So you can have you can be capable of several capabilities.
Right.
It doesn't have to be just narrow means one.
Yeah.
But I think I do. I don't know. I think I do view AI coding assistants as narrow in the sense that they're really trying to do one thing. You would. Here's maybe the litmus test. Would you go grab one of those models and use it for some other language task as a starting point? Probably not. You probably would. You'd probably use something that was more general in nature.
Yeah, that's the point.
Right. Yeah. But for coding agents, would you fine-tune that model on your own data? That's a question I often think. Do I want to fine-tune? Because the cost of fine-tune is getting lower. Like thinking machines, their Tinker API, you can fine-tune using $5, $10. You can fine-tune a LoRa. You download it. Yep. But then is the quality improvement using your own code make up for whatever you invest, or is it better to wait for Cloud and OpenAI or whatever other companies come up with their new version?
Yeah. I think it's probably the latter, and I think for a couple of reasons. One is things are moving so quickly on the AI coding front that it's almost certain that within 6 months there'll be another quantum leap on that front, and you can just wait and leverage that, not have to spend any money. The other thing is that I feel now with the ability to specify and have things like skills and other directives, you can describe the type of coding that you want to be performed, and you can kind of guide it in a way that doesn't necessarily require fine-tuning. That said, I do think if you were going to convert legacy applications, move from COBOL to Python or something like that, that might be an area.
Fortran.
Yeah, that's a good point.
All right, Zizi, what do you think, sticking with that theme, what do you think about the idea of not encoding agents, but just fine-tuning a model? If I took a large language model and I fine-tuned it, would you consider that a domain-specific model?
Yeah, we're actually actively considering that in the project that we're working on, tax processing. We're right now, we build a, kind of a sort of an agentic system that uses the cloud API to and in combination with the OCR model to feed the extracted content and then to parse it.
And this is for extracting information from documents.
Yeah, extracting information from complex tax documents with very dynamic schema, and it could be not just one tax form, but could be many forms all together in one package, right? So it's working fairly well with the API. I think it's a good starting point. That's another benefit of such frontier general models is that they give you a strong baseline.
Yeah.
However, we found that there's hallucination for sure, because if the model has to reason across multiple pages, oftentimes it confuses itself. Hey, which page should I look at to extract a certain type of information?
Yeah.
So we are running experiments and planning to run more to fine-tune both the OCR as well as the reasoning model to just to improve more accuracy and to reduce the hallucination. And I think possibly we can also fine-tune a verifier model that takes the document and takes the extraction output and then just do the verifications and trying to output a confidence score, because that's a missing piece for a lot of the off-the-shelf models. Right. And I think we can use SuperRock's fine-tune, and we're working on reinforcement learning to fine-tune such models, and I'm super excited that and looking forward to better performance.
All right, so there's one more area that I want to hit upon that I think is really, really interesting. And actually, Zizi, you touched upon this a little bit earlier when you were talking about latency and other sort of, I think most people most businesses, when they're building something, they're building an AI solution, they're really just thinking about like how good can it be, like how accurate, right? But there are a lot of other things. There's cost of ownership, right? That they can be really, really expensive to build models.
Right.
There are things like, governance. There can be proprietary issues around the data, or maybe even privacy constraints, right? I mean, all these things really factor in. And across the board, again, domain-specific models have so much to offer there because they're, like you said, Michael, they can be many orders of magnitude smaller, which makes them much less expensive. It means you can put them on the edge, right? If you have really low compute capabilities or compute constraints. Yep. To your point, ZZ, if you have latency issues, really, really effective there. So for me, the idea of companies that are taking their first step into AI and they're trying to figure out what to do, it is this simple. Be focused. Look at what data that you have that is proprietary, that you can use to build domain-specific models that allow your business to introduce new capabilities, reduce the cost of existing functionality within the company, whether it's client-facing or internal, and give you real competitive advantage. Not to mention all the other things we've talked about, that these things are easier to train, evaluate, govern, and less expensive to maintain. So for me, again, just to reiterate, I'm completely with you guys. Large language models are astounding. They're amazing. There are boundless instances where they are the right choice. But for most enterprises, I think we all agree, think more specific. And if you can constrain your requirements and leverage proprietary data, you're going to have a much, much more likely chance of having that AI investment that everybody's spending right now be successful and go into production.
Such a great point.
Here, here.
All right. You guys, any other thoughts here?
Speaking of latency, I thought of some examples and actually more broadly, I'm just looking back at the projects that we worked on and trying to think, okay, with today's technology, would you redo?
Would you do it different?
Yeah. Would you do it differently?
That's a great question.
And surprisingly, when I think about the projects that I worked on, I would say most of the project I would still not use the large language model or diffusion model, the frontier models of today to solve it. One example is real time ads bidding. It's a
like
10
millisecond
latency constraint.
That
most of the model is just out of the way.
Yes.
And we just have to use a very small either tree-based model or linear model.
Yes.
And we need to cache the hell out of the system to
that is a really great perspective, which is retrospectively, would you change how you architected something? This is over the last 8 years, and the answer is, for the most part, no.
Right. Surprisingly, I would think that for example, Clarity, where we build a image-based model to predict the cancer risk for the next 5 years.
Yeah.
I'm curious, Ron, what's your opinion with the latest VLMs?
I totally know. I completely agree. I think the approach, just taking a complete image-based approach, is 100% the way to go. And I love this. It's like, this model can only do one thing. All it can do is predict the risk of breast cancer. But one thing,
good at it.
It's really good at it, and it's going to save millions of lives.
Right.
And that's a perfect example of the power of focusing your solution and not trying to boil the ocean.
You know what I would wager, though, is that the process that we would have taken to get to that result would have looked wildly different in almost every project still. I mean, with like the advent of coding assistants.
Coding agents. Okay.
Coding
agents.
If we had like even just debugging tools.
Oh, yeah. Absolutely. Deploying tools. Yeah.
Deployment tools, like all that stuff. I think it'd be fun if we could just magically rewind the clock and go back and relive some of those big moments.
Well, there are certainly some projects I remember from, 7, 8 years ago that were bleeding edge, and, it took every brain cell we had to accomplish. And now I think we could do those in, a tenth of the time, right?
Yeah. Yeah, I remember the first document understanding project where we still train these, very specialized object detector to detect the small fields.
Yeah, to even find the fields, right? Yeah.
And then OCR.
Yeah, we did some wacky stuff back then.
Well, AI just keeps on changing, keeps on moving. Okay, well, I think that's a great point to stop right there, guys. Thanks so much. Happy New Year, and thanks for being here.
Thank you.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.